Given that z is equal to e to the power xy, x is equal to 2 squared, and y is equal to 2t to the power 3, find dz dt. So when you look at this, the z function is having two variables. That means we are dealing with a multivariable function. And we are going to employ what we call the multivariable chain rule, or in short, I can just say the first chain rule of calculus involving several variables. So we are going to employ what we call the partial differentiation in order to help us find dz dt. And how do we do that? So dz dt, if you recall from chain rule, is that chain rule usually allows you, let's say if I'm finding dy dx, right, you are going to get something like dy, maybe du, then multiplied by du, and let's say dx. This is chain rule. That's how we used to do it. These can be anything, such that when you cancel them, they are still taking you back to your required approach. So now, having known that, so we are going to apply the same for this function having x. So we are going to differentiate this z with respect to x first. Now, partial, because there are two variables there. All right. So this will be dz over dx. So we're differentiating this one with respect to x. Then the same way, what we do, we multiply. We differentiate now this one here with respect to x as well. That would be dx with respect to t now, such that these can still cancel and they give you dz dt. Plus, we have another function here. Okay, we have another function. So this will be dz over now we differentiate this one in terms of what? Y multiplied by differentiating this one with respect to t to give us dy dt. So now let's now find this dy dz. So what is the derivative of this with respect to x? So this with respect to x, remember, again here you are going to apply the chain rule. You differentiate there, you multiply by whatever that remains, you get your answer. So if I differentiate here with respect to x, I'm just going to remain with y, and I'm going to drop the y down. So I'm going to have y, then e to the power xy, multiplied by dx dt. This one with respect to t is going to give me what? 2t plus dz dy. Coming back here, differentiating this one with respect to y you will go, I'll remain with x. So that will be x e xy multiplied by differentiating this one with respect to t to give me 3t squared. You have those, then what we do? We just now have to do what? To substitute. But take note, something is must be done here. Okay, something must be what? Must be done. Something simple, in fact. All right, so here's what we are going to do, ladies and gentlemen. What is y? Y is t to the power 3, so replace that. Okay, then we've got t. Okay, e to the power that. So this will be e. What is x? X is t squared, so put t squared. Then y is 3 squared, so we multiply by that. Again, we're multiplying by 2t plus. What is x? X is t squared. Then e, what is x again? X is t squared multiplied by t to the power 3. Again, multiplied by 3t squared. Now we can multiply here. Okay, multiplying here, this will give us what? 2. Then we have t. You can clearly see that here we get 5. You are aware, right? Here we get 5, but you have 3 here and we have a 2 here, which will give us 4. So you have a 1 there and a 3, which will give us 4 when you multiply, because they're multiplying same bases by indices. These two, you add the powers, because they're the same bases. You add the powers, which will give you e t to the power 5. Plus, here we have 3. There's a 2 here and there's a 2 there, which will give us t to the power 4. Then e to give us what? 5. You know that you can add these because they are like terms. This will give us what? So dz dt just equal to 5 t to the power 4, then e to the power 5. Cheers.